Hello everyone, today I'll be covering projectile motions. At the beginning of the video, there is actually the problem that we need to solve. So basically we are given two balls that are both have been launched at the same elevation and with the same initial velocity. And the initial velocity, V0, was given to be 30 meters per second. Now, what is very important about the problem is the fact we're given two balls. So the ball one was launched at, let's say, at angle theta 1, and then the second ball was launched at a different angle, angle theta 2. So what is very important here, what we are told is that theta 1 and theta 2 are complementary. What that means is when we add theta 1 and theta 2, we should get 90 degrees. And now the question becomes, will they land at the same location? In other words, will the range for ball 1 and range for ball 2 will be the same? Will it be equal? That's the question, and we need to prove it in this problem. Now, I'm just putting it here as a reminder of what we're trying to do. Now, initially, for every projectile motion, it's good to start with your equations, which is your v equal v0 and plus at and then v squared and all that. So all these three equations. Now, for any projectile motion, if you want to be able to solve any projectile motion, I guarantee you, as long as you separate your motion into horizontal and vertical motion, you will always get it right. So here what we're going to do, I will divide this into two. I will have the horizontal motion and then the vertical motion. What does that mean? So when the ball is in the air, right? So go ahead and draw that here. So if you launch a ball from here, it will have a projectile motion, right? So let's say we have initial velocity v0. What is going up? It will have a upward. It's going up at the same time. It's going like vertically and horizontally because it's going to move like this, right? So the v is changing, right? So let's say here, you're going to have a v going here and then a v going here. So it has two motions. It has a horizontal, it has a tendency to go up. At the same time, it's also moving this way, right? Now, to do this, we know that the v0 will have two components. It will have a vx corresponding, right? And then we'll have a corresponding on the y-axis, so a vy. Now, this vx will be valid for the horizontal motion, and the vy will be valid for the for the vertical motion. All right. So let me go ahead and rewrite my equations in terms of horizontal and vertical motion. All right. So horizontally, if I use this one, we know that when it's going to horizontal motion, there is no acceleration. So a is 0. Now we know that for horizontal motion, Vx is just equals to V0x, right? Nothing interesting happening here. Now, what is this equation going to be? Same thing. Acceleration is 0. There's no gravity on a horizontal motion. So this also V squared equals to V0. It's the same thing as saying Vx equals to Vx. Not very interesting. However, this one, when we look at it, we're going to have x equals to x0 plus v0x t plus what? Half at squared. What is acceleration in the horizontal motion? 0. So this is plus 0. So we just have x minus x0 equals to v0x t. Now, x minus x0 is saying this is the final x. So if we are to launch the ball, right? Initial x is right here, x0. It could start from here, but let's say that here x0 equals to 0 initially. And then it ends right here. So this will be x. So x minus x0 will be our range. So you can go ahead and call this r, as being the range. So here we're dealing with ball 1. So r1 equals to v0x t. Now I said earlier, since the v0 will have two components, a vx and a vy. Now the angle launched will be here, so theta 1. So now Vx, since it's touching the angle, that will be V0 cosine theta. And Vy equals to V0 sine theta. So you can go ahead and substitute that here. So R1 equals to V0 cosine theta t. So let's call it theta 1. Now this is R1 in terms of t. How do you find t? In order to evaluate t, we need to know at what time does the ball reach its maximum height. When it reaches the maximum height, it stops moving. So here v equals to 0. So v final equals to 0 at maximum height. So we can evaluate the time it takes to go to the maximum height and then multiply by 2 to give us the total time. So let's go ahead and do that here. We can go ahead and rewrite our equations for the vertical motion. So Vy equals to V0y plus AT, right? Again, we're just rewriting the expression in terms of vertical and horizontal motion. This one has T in it, it has A in it. What's the acceleration for vertical motion? Is G, so it's acceleration, so it's going to be minus G, so it's going down. Now, so this equation is actually enough for us. Now we said at the maximum height, so at max height, Vy equals to 0, right? So the final velocity is 0. So then we can set this one 0 equal, now what is V0y? We say V0y equals to V0 sine theta 1 plus, but since acceleration is going down, so it's negative gt. So we can go ahead and solve t. So t equals to v0 sine theta 1 divided by g. Now this time is the same time that, this is the time that would take for the ball to reach its maximum point, h0. I'm sorry, maximum height where v equals to 0. Now to get the total time to cover this range, we have to multiply by 2. So now the total time, I can call it, just let's call this one maybe t prime or something, and then call this one the final t, right? Now the t equals to just twice of this, so 2v0 sine theta 1 over g. Now this is the same time that it will take for the ball to go to full range. So you can go ahead and substitute here. So R1 now becomes v0 cosine theta 1 times what? 2v0 sine theta 1 divided by g. So you can simplify this to become 2v0 squared cosine theta 1 times sine theta 1 divided by g. Now this is R1. Now we need to check if, yeah, of course the v0 is going to be 30 meters per second. You can substitute that. But now we need to verify if R2 will be actually equal to the same thing as R1 to answer the question, right? So again, to recap, the question is, will the R1 be equal to R2? Now this is for ball 1. Let's go ahead and do for ball 2. If you remember, I said that the angles of the two balls are complementary, meaning that theta 1, so I'm just going to put a reminder here, theta 1 plus theta 2 equals to 90 degrees. Right? So ball 2, same thing. We're going to divide our motion into horizontal and vertical. So horizontal motion and vertical motion. So here, same thing. So we know that this is not very useful, but we know that the second part, x equals x0 plus v0 xt, that's what we need. That would give us R1, R2. So we know that x minus x0 equals to v0x times t. What is this? This is now going to be R2 for the second ball. v0x is v0 cosine theta times t. So here is theta 2 though, right? Now we know that since theta 1 plus theta 2 equals to 90 degrees, what this means is theta 2 equals to 90 minus theta 1. So R2 therefore equals to V0 cosine of theta, cosine of 90 minus theta 1 times t. Now how do we evaluate the t? We use the same idea here. So V, again, on the vertical motion, we look at what time would ball 2 reach its maximum height. So that would be, so Vy equals to what? V0y plus AT. Now, maximum height, v0y equals to 0, vy equals to 0 at maximum height. Now, v0y will be v0 sine theta 2 minus gt. So we can evaluate t to be equals to v0 sine theta 2 over g. Now again, this is just a half time, right? So the total time, we could call it t prime, maybe, right? So now the time, the actual time would be 2v0 sine theta 2 over g. Now this is the same time that we take for the ball to cover R2. So go ahead and substitute. So R2 equals to v0 cosine 90 minus theta 1 times t. Now we said that since theta 1 and theta 2 are complementary, theta 2 we said equals to 90 minus theta 1. So t actually equals to 2v0 sine of 90 minus theta 1 divided by g, right? So go ahead and substitute that here. So this will be 2v0 sine 90 minus theta 1 over g. So go simplify. So we know that cosine, since they are complementary, all that means is cosine of 90 minus theta 1 equals to sine of theta 1. And sine of 90 minus theta 1 equals to cosine of theta 1. That's what it means by definition, two angles being complementary. So we can go ahead and substitute this value in here as sine theta 1 and this one as sine theta, as cosine theta 1. So now R2 becomes V0 sine of theta 1, right? Substituting this whole thing as sine theta 1 times 2V0 sine of 90 minus theta equals to cosine theta 1. So times cosine of theta 1 divided by g. We can simplify this one further. R2 equals to 2 V0, so that's V squared sine of theta 1 cosine of theta 1 divided by g. If I rearrange this, I will get 2 V0 squared cosine of theta 1 times sine of theta 1 divided by g. And as we can see, indeed, R2 equals to R1. And we can say for sure that the two balls will land at the same location. I hope this makes sense. If you have any questions, please leave in the comment section. I highly recommend that you try to redo the problem on your own. But that's it. And thank you for watching. Have a great day.